Hello, this is Mr. Craig, and I might make a second video, but this is definitely the first video, and this is the Thanks Taylor extra review here. Okay, so let's get right to it. Number one says, neutralizing 1.55.2 milliliters of a 3.7 molar nitric acid solution requires 67 milliliters of potassium hydroxide. What is the molarity of the basic solution? And then I gave you the reaction is potassium hydroxide, so we have a base here, plus nitric acid, and we have an acid here. And how do we know we have an acid and a base? Well, a base will always end in hydrogen, where the acid will always begin with hydrogen. Remember that. Now again, if it has a hydrogen at the front and at the end, it can be either an acid or a base. But I won't do that to you this year. In AP Chemistry, I'll sock that to you. But do realize that you have an acid and base, which is a neutralization reaction, and it is a double replacement reaction, which means that the metals are going to switch places, partners are going to change. So on the other side, the potassium is going to be with the nitrate, and the hydrogen is going to be with the hydroxide, forming water or HOH. However you want to write that is fine. Alright, so recognizing that we do have a neutralization reaction, we do have a nitric acid solution, and this is our volume for our acid, this is our molarity for our acid, and then it says requires 67 milliliters of potassium hydroxide, so that's the volume of our base. So if you want to write the variables above, it's probably not a bad idea. So we're going to use this equation here, MAV, ooh, that should say A right there, sorry about that. It's going to be equal to MBVB. Holy cow, that is really, I got to fix that. Sorry about that. So your A's are on one side, the B's are on the other side. Alright, then we're going to rearrange since we are looking for, we know our VA, which is this one right here. We know our MA, which is that right there. We know our VB, which is that. So we're actually looking for our MB here. Okay, so we want to rearrange the variables. So we're going to take VB and move it on down. So now that we have our equation, which is given here, okay, so once we have the equation, go ahead and plug in the variables that represent each other. Now we don't have to change the values here to liters unless you're just dying to. Just realize that the volumes will cancel out. We're left with our molarity. Alright, hopefully that wasn't too bad. Number two, it says in a solution of water, the concentration of the hydroxide ions is 2.85 times 10 to the negative 6. What is the concentration of the hydrogen ions? Now again, recall that the information that's given here is our amount of hydroxide. So that's what this is. Also, you were given an equation, which is on the back of your periodic table, or it'll be on your exam sheet. I can't remember where I placed it, but I do have this constant, where the hydrogen times the hydroxide is equal to 1.0 times 10 to the negative 14. So we know one of these. We know the hydroxide and the constant. So we know two of the three. We're looking for the unknown. So since we know the hydroxide, we need to slide it down so that we isolate just the hydrogen ions all by itself. So now we have our equation that looks like this. So we have we're looking for our unknown, and we put our knowns on the same side of the equation. So once we have the knowns on the same side of the equation, now we can take that number, take this number, and plug it right in. So once we plug that in, then we can solve for what the hydrogen concentration is. So again, take what you know, or what's given, and divide it by, the constant divided by what was given to get your answer for our hydrogen. And yes, I would like to see at least this amount of work on your test. Okay, you don't have to show each one of these steps. That's just more for me to demonstrate how I got to that process. Okay. Alright, number 3 says calculate the pH of a solution with a hydroxide concentration of 2.55 times 10 to the negative 6. So we're looking for pH here. Okay. However, we're given a hydroxide concentration. So probably one of the first things that we need to do is find the pOH. Okay. Since we have the hydroxide concentration, let's try to find the pOH first. So we know that the hydroxide is 2.55 times 10 to the negative 6. Okay. This is one way you can do this. We can actually find out what our hydrogen concentration is by doing what we did up here. Okay, very similar. So we can calculate our hydrogen concentration and find out that, okay, I know my constant is this. I have a concentration, and again, these brackets mean concentration or molarity. So I can calculate my hydrogen based on that. So here's my hydrogen concentration. Once I have my hydrogen concentration, all I need to do now is take the negative log of my hydrogen concentration that I now know. And I think that's what I have in the next step. So take the negative log, and again, this equation is on your equation sheet, and then just plug that value in. Okay, so we should get a pH of around 8.41. Now, there are many ways of working this out. That's one way. Another way is, again, we know that pOH, okay, if we have our hydroxide concentration, and we do, which is given right here, okay, so we have our 2.55 times 10 to the negative 6, so we can actually just find the pOH, and I bet most of you would do this. Plug in your 2.55 times 10 to the negative 6, get your pOH, and then realize that pH plus pOH equals 14. So we want to place our pOH, actually we want to rearrange this. Since we're looking for the pH, we need to subtract the pOH on both sides. Okay, so once we subtract the pOH on both sides, now we have this equation right here, which is pH is equal to 14 minus pOH. Then plug that value right in, and you get the same number, and you should get the same number. There's a third way you could do this, and again, I don't care how you do it, just as long as you show me all the steps that are required for you to get your answer. What I despise is for students to just do all this work in their head and then type it in on their calculator and write down 8.41. You're going to miss a lot of points doing that. You need to show me how you're getting your answer. That's the way it is on the AP exam. They don't accept just answers. So the process is more important than the answer itself. I can give you credit for the process. If you just have the wrong answer, you lose everything. All right. So the other way that you could do this is realizing that you know that the pH plus the pOH is equal to 14. We could rearrange the equation like we did in an earlier step and go right for the jugular. So we know that the pH is what we're looking for. We know we have to do 14 minus that. Now what's really cool is the pOH, which we found up above, right here, okay, that can be actually inserted into the equation. I mean, we can find the negative log of the hydroxide concentration. This is my pOH right there. So I just take 14 minus, put in parentheses, the negative log of 2.55 times 10 to the negative 6, and I get my answer. Again, I don't care how you get your answer, just as long as you're showing me your steps and your process. Okay? Alright. Number 4. An acid has a pH of 3.43. What is the hydrogen concentration? Okay? If you know the pH and it wants to know what is the concentration, we have to use the antilog. So what we need to do is we need to take the antilog of negative 3.43. And again, this equation is on the back of your periodic table, so, or it'll be on your test sheet. I don't remember where I put the equation. I haven't made the test up yet. So take the antilog, which is second log, and then negative 3.43. So the antilog, and that should be your answer right there. Okay. So 3.72 times 10 to the negative 4. All right, number 5. Completing the table, when you see a question like this is strictly calculator work. Not a problem. I have no problem with you not showing any work doing this. So some of you are just absolutely loving this. Now, I will work out a couple of these problems for you. So let me move this up and I'll show you how. Okay. The bold black are the answers, and the light, like this was given, that was given, that was given, and that was given. And expect something like this on the test. I promise. This is great work for you to do. Okay, no problem here. So let's go ahead and start. Let's find out what our hydrogen concentration is if we know our pH. So again, just like in the previous question, if I'm looking for the hydrogen concentration, okay, and again, you don't have to show the work on this, just know how to type it in. I'm going to take the antilog of a negative 9.2. Okay, so that's what I want to type in on my calculator. Now, I found this really neat calculator here. Let me actually get it so you can still see what's going on here. Well, I don't say it's neat, but it works for what I'm trying to do. So we're going to go, this is second log on this calculator, and negative 9.2. So it should equal 6.31 or 30. So the bad news is it doesn't put it in scientific notation. At least I haven't found that. So 6.3 times 10 to the negative 10. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, so that's good. Okay. And then once we have the pH, then we can find the POH simply by taking 14 minus that. So the POH, 14 minus the pH, which in this case is 9.2. So if you can do that in your head, that's great. So 4.8, no problem there. Now, getting the hydroxide concentration, there's a couple ways of doing that. Probably one of the easier ways is by taking the antilog. So if you know the POH, so take the antilog of the negative POH value. Okay, since we're looking for hydroxide here, so antilog, and you don't have to write out the OH, just you can go right for the negative 4.30, sorry, 80. So looking at that, we'll type that in. So clear that. Again, that negative 4.8, close it up, and then we get 1.58. So that's 1, 2, 3, 4, 5. I hate that this doesn't have scientific notation. So 1.58 times 10 to the negative 5. Okay. All right. Let's look at the next one here. We'll do the hydrogen concentration. So I'm given the hydrogen concentration, and I want to find pH. So again, I know my hydrogen concentration. If I know the concentration, then I just simply take the negative log of my hydrogen concentration to get my pH. So negative log of 2.05 times 10 to the, what is that, 1, 2, 3, 4, 5. Okay. So whatever that is, so clear that out. Negative log, what is that, 2.05, 10 to the, was it negative 5? Yeah. So 4.69, somewhere in that area. Yeah, 4.69 right here. Alright, so that's how you use your calculator. And if you need to see the process again, just rewind the video here and try it. Alright, in questions 6 and 7, identify the acid, the base, the conjugate acid, and the conjugate base. Alright, here's what we have to do on questions like this. We have to look at the before and after. So when we know that acids and bases can only be on the reactant side or the left side, conjugates can only be on the right side or the product side. Acids behave as acids, bases behave as bases. So acids donate hydrogen where bases accept hydrogen. Okay, so looking at the first one, we have water where it has 2 hydrogens, here it has 3. So what is the water acting as? An acid or a base? Well, again, it has 2 over here and 3 over here, so that means that it accepted a hydrogen ion. So that means if it accepted a hydrogen ion, it's acting as a base. Looking here, we have 1 hydrogen here, and that hydrogen is gone. That means that it donated a hydrogen. Alright, to get the arrow to go back in the reverse direction, this H3O going back to H2O has to donate a hydrogen. So this is acting as a conjugate acid, or this is acting as a conjugate base. Now, remember this. If I'm an acid on the reactant side, I cannot be a conjugate acid on the base, or I'm sorry, on the product side. So I have to be the opposite. So if I'm an acid on one side, I'm a conjugate base on the other. Okay. Alright, let's look at the next one here. Alright, so we have carbonic acid, H2CO3. We have 2 hydrogens here, where we only have 1. Here I have hydrogen in front and hydrogen in the back. But what I want you to realize is that the before and after. How many total hydrogens does this have? It has 2. On the product side it has 3. So we have to assume that it is accepting a hydrogen. So this is acting as a base, this is acting as an acid. Because again, there's 2 hydrogens here where there's only 1 here. And then to get it back, we have to flip it. So this is acting as a conjugate acid, and this is a conjugate base. Now what I want you to recognize on both of these is looking at this one, there's no charge, no charge, no charge, no charge. Now again, sometimes they'll both have no charges. However, the charges always change when we donate a hydrogen. So looking at the water, looking at the water here, it has no charge. What did it do? It lost a hydrogen ion, which is a +1. So on this side, I'm sorry, it gained. It hadn't, since it's a base here. So it gained a +1. So its charge on the product side should be +1. The perchlorate had no charge, and it lost the +1 charge. So it became more negative on this side. Okay? Same thing happened on this side. We have to be aware of the charges. Even though this question here doesn't ask for charges, I want you to practice that because most of you are still very weak at writing the charges down. Alright. I like these questions a lot. Here we go. We have H2CNNH2. We don't need to know the name of that. That's not one of our acids or bases that we need to know. It says it's a conjugate base. This is a conjugate base. It wants to know what is its acid. Okay? When we're talking about what is its acid, we're talking about what is this before it became a conjugate base. Okay? So if we know that this is a base, okay, how did it become a base? Well, it acted as an acid on the other side. So if this is my conjugate base, okay, then that means that it actually gave away a hydrogen on the other side. Okay? Or, even better, sorry, let me scratch that, is a conjugate base, so that means it's going to accept a hydrogen from whatever is the conjugate acid on that side. So it wants to know what is its acid, so we have to add a hydrogen to this. Now typically when we add hydrogens, we add them at the front. Okay? I'm not a big stickler yet. In AP Chem we'll talk about where to place the hydrogens. Just try not to put them in the middle. So this should have one more hydrogen. If you put it on the front or the back, I'm okay with that for now. Alright, now over here there is no charge, but it gained a +1 charge. So that means that we have a total charge of +1. Okay? Now if you need to do it like this, okay, that's fine too. So if you want to say, okay, and set up something, and it doesn't matter what you're doing, but I mean what your acids are and what your bases are. If you want to make that water, that's perfectly fine. But the key here is I'm focusing on that right there. Alright. Number 9. What is the base for CrO4 -1? Okay. So if it's asking what is the base for this, this has to be acting like an acid, or actually a conjugate acid. So what do conjugate acids do? They give away a hydrogen. So if we're looking for the base, because again, if like up here, the acid gave away a hydrogen to the water, and then we had one less hydrogen on this side, and this had one more hydrogen. To get it back, it needed to gain a hydrogen. So my base for HCrO4 should be just CrO4 with a -2. notice that it has a -1 charge. If it loses a +1, then it becomes more negative. Okay, so chromate is our thing there. Okay, so what is the base? Again, bases are on the reactant side, conjugates are on the left side. So the base for this conjugate acid, there's my conjugate acid. It gave away a hydrogen, and again, it doesn't matter what you're reacting it with, but it should have one less hydrogen. And for the CrO4 -2 to become HCrO4 -1, it had to accept the hydrogen from the acid itself. Okay. Number 10. What is the acid for this base? That's how I want you to read this. So up here, what is the base for this conjugate acid? So here, what is the acid for this conjugate base? So if this is a conjugate base, it should be accepting a hydrogen. Okay. So where are you going to put the hydrogen? Put it up front. So H2CH3 NCH2. Now, what's my charge on this? 0. It gained a +1, so it should be a +1 charge. Okay. Are these starting to get a little easier? Okay. So it should, and I put it on the, oh, I didn't put it in. Oh, I put it right here. Now, wait a minute. Sorry guys, that should be that should be that. So ignore that and that. Well, the 2's okay. The 3, I don't know where that 3 came from. Sorry about that. Yeah, that's crazy. Alright, so this is the correct answer. Okay. Number 11. What is the conjugate acid for this base? Okay. Conjugate acid for this base. So bases accept hydrogen. Okay. So if it's accepting a hydrogen, then it should be H2SO4. This has a -1 charge, so if we take a -1, add a +1 to it, what should my final charge be? 0. So there's my answer, H2SO4. Okay. And these are really the difficult questions, I hate to say it, from 8 through 11 probably are the big concept questions that even the AP students have questions about. So if you can figure this out, I mean, if you can master this trait, you're in great shape. Alright, number 12, calculate the pOH of a solution that has a hydrogen concentration equal to 3.33 times 10 to the -3. Very, very similar to what we did earlier. Since we know our hydrogen concentration, which is that, we can do it one of 3 ways if you want to. Realizing, oh yeah, making sure that you know that this is the same thing as this is really important. I don't want a lot of people freaking out going, oh, where's the 3? Okay. They're the same thing. Also realize that we have our hydrogen times hydroxide is equal to our constant. Since we know what the hydrogen concentration is, let's rearrange the variables so that we get the unknown all by itself. Plug in what we know, and again, this is just one way. So we know that our hydroxide concentration is 3.0 times 10 to the -12, and then we can, actually it's just looking for the pOH, so then we can take our negative log of the hydroxide concentration and we get a value of 11.52. Now admittedly, this is the longer way of doing it, which is okay. Another way you could do it is, if you know the hydrogen concentration, which we do, then just find the pH of this. So we get a pH of 2.48. You know that pH plus pOH equals 14. Take the difference of those two, we get 11.52. And I would dare say that most of you would do it this way, and that's fine. Some of you may realize, hey, I've got my hydroxide concentration, or I'm sorry, I know my hydrogen concentration, and I can go right for the jugular here and just find out if I know pOH is equal to 14 minus the pH, plug in my value here to get my pH value. So 14 minus my pH is equal to 11.52. Whichever way is comfortable for you, again, I don't care which way you go. Alright, 13, calculate the hydrogen concentration if you have a solution with a pOH of 10.72. I'd be willing to bet that most of you would do it this way. Just automatically find out what your pH is. So pH plus pOH equals 14. Your pOH was given as 10.72. Take the difference of the two, so we get a pH of 3.28. Then all we have to do is take the antilog of the negative pH value to get our hydrogen concentration. Is that it? Oh, yeah. Simple. Alright, sorry about that. I thought there was more to that. Alright. Number 14, here we go. The following substances act as Bronsted-Lowry bases in water. Okay? Act as a Bronsted-Lowry base in water. Write the chemical equation for each that illustrates the reaction with the water. Okay, so here's what the question's asking us to do. We're going to write NH3 reacts with water. Okay? This is my base. What do bases do? They accept hydrogen. Now, if you need to draw the arrow, that is fine. Okay? So since it accepted a hydrogen, it is now NH4 with a plus 1. And the water now is hydroxide. This is what the question is asking you to do. If it says it's acting as a base in water, show me water, show me it as a base, and what's happening. Okay? Not difficult. And a lot of you did very well on this on the quiz, so I was pretty proud of you on that. All right, double I. Again, it's acting like a base, still same part. So HCO3 -1 plus water. And yes, do be careful with your charges here. They are important. So again, this is acting as a base. So that means it is accepting a hydrogen. So if we accept a hydrogen, again, put it on the front. So H2CO3, and our water turns into hydroxide. Now, this has a charge of -1. This has no charge. This has no charge. This has a -1. What I want you to realize when writing these equations, that the charges on both sides of the equation should be the same when we add them together. So looking at part I have no charge plus no charge equals no charge. On the right side I have a +1 minus 1, which equals no charge. So that equation's good. In this equation I have a -1 charge plus a no charge equals -1. Here I have a no charge plus a -1 equals a -1. So the charges have to be the same on both sides when you finish with the problem. Okay. Alright, and the third one here, again, we're still behaving as a base here. So HCrO4, -1, reacting it with water. Okay. So it accepts a hydrogen from the water. So we, again, put our hydrogen at the front, H2CrO4. Since it has a -1, it will have no charge on the right, and our water is now hydroxide. Okay, -1 plus 0 equals -1, 0 plus -1 equals -1. Alright, not difficult, I hope. And again, these types of problems, all we're doing is moving one hydrogen, and we're moving one hydrogen, period. Okay, so these were all acting as bases. Next part wants us to treat these as a Bronsted-Lowry acid in water. Okay, so if we're looking at acids, what do acids do? That's right, they donate their hydrogen. So we have our HF with water, and yes, we do want to show the water because it says it's reacting with water. So double arrow. This is my acid, so it's going to donate my hydrogen. So I'll have one less hydrogen. Now, since we have given away a +1 charge, my fluorine ion has a -1 charge. The water accepted that hydrogen, put it up front, so H3O with a +1. No charge plus no charge equals 0. -1 plus 1 equals 0. Okay? H2PO4 -1. Okay. Okay, H2PO4 with a -1 charge. Again, reacting it with water. This is acting as an acid, so it's going to give its hydrogen away. So it should have one less hydrogen. Okay, since there's a -1 charge here, what should the charge on HPO4 be? That's right, -2. Then we're going to add that hydrogen, so H3O+. Okay. So -1 plus 0 equals -1. -2 plus 1 equals -1. Everybody happy? One more, last one. Acetic acid, HC2H3O2, reacting with water. So again, it's acting as an acid, so it donates its hydrogen. So we'll have just acetate ion. And again, it's nice to know these polys. It's a -1 there. And then we'll have H3O with a +1. Okay? I think that's all of our examples. Okay? Well, I do hope that this video has helped. I'm going to try to make the Katie video. Not sure when I'll do that, but I hope this video has helped. And if you do have any questions, guys, don't wait until we meet again in class. Email me, let me know what you have concerns about. As always, I hope this video has helped.